Hi, this is Chris McClune with Vision Systems Design, here again at Vision 2022. I'm at the Euresys booth now with Mark Demolt. He's the CEO of Euresys. We're going to talk a little bit today about how Euresys is advancing different camera standards, in particular CoaXPress and GigE Vision. So Mark, we're going to start off with CoaXPress here. Why don't you tell us a little bit about what's going on here?
Thank you, Chris. Euresys is a manufacturer of frame grabbers, and the CoaXPress standard has been our #1 interface for years now after Camera Link. Here we have a new solution, which is our Proxlink QSFP Plus frame grabber. What does QSFP Plus mean, and what does CoaXPress over fiber mean for the industry? Our customers today are using CoaXPress for high-speed application, for high bandwidth application. Our #1 product is a Quad CXP12 frame grabber. With the Quad CXP12 link, we have access to 4 links at 12.5 gigabit per second. This is a total of raw bandwidth of 50 gigabit per second, 40 gigabit per second net bandwidth. What we are doing with this solution is that we are moving from copper and the coaxial cables of CoaXPress towards fiber. It is a very, very important design point here. Our Coaxlink QSFP Plus uses a standard transceiver which is used by a networking application. This means that we have access to very low cost, very standard, very easy to source networking equipment as the physical layer of a CoaXPress over fiber. This is the solution that we are promoting here at the show. Along with different camera makers, we have actually 5 different brands of well-known camera makers that have started to build CoaXPress over fiber and the QSFP Plus cameras.
Well, now we're at the GigE Vision demonstration at the Euresys booth. So Mark, why don't you talk a little bit about RDMA streaming and GigE Vision and how Euresys is all a part of advancing this?
So here we have a product and a kind of demonstration which are entirely different. One of the products of Euresys is a set of IP cores. IP cores are kind of FPGA software or software for FPGAs that we sell to camera makers and designers of embedded systems to include protocols into their camera or into their system. What we are demonstrating here is high-speed streaming for GigE Vision using remote DMA, and in particular here Rocky V2. Remote DMA allows us to stream data up to 25 gigabit per second, 25 gigabit per second. So we see it, the IP core is actually implemented in this FPGA, and we stream data over this fiber at 25 gigabit per second. What is interesting with this solution is that it's an IP core which will become a standard product and which will be connected on the receiver side to standard network cards. So no need to have a particular dedicated network card. Here we are talking about an IP core at 25 gigabit per second compatible with standard network cards on the market.
Now we're here at the OpenE Vision demonstration area at the Euresys booth. We're going to talk about OpenE Vision, which again is a set of image analysis libraries, and Mark's going to take us through what we're looking at here. Mark?
Thank you, Chris. So OpenE Vision is a set of libraries that we mostly use for inspecting objects, detecting defects, identifying objects, reading characters and codes. What is new here on the booth is that we have recently introduced an embedded version of OpenE Vision. This embedded version runs on ARM chips running the Linux operating system. Of course, we still have the normal version of OpenE Vision running on Windows on a standard Intel chip. Here we see OpenE Vision running on this smart camera. It's a Baumer camera with a Jetson Nano embedded inside the camera. We have our easy segment deep learning libraries running inside the camera and detecting foreign materials in coffee beans. You can check the image on the display up there. We are able to detect really difficult to see foreign materials among the different grades of coffee beans.
Okay, and to round us out, why don't you talk a little bit about EasyOCR and our next demonstration area.
So the next demonstration is also Open eVision, but this time running on the very small and low-cost Raspberry Pi. I'm sure that everyone knows the Raspberry Pi. It's also used actually in quite a number of industrial applications. So with this demonstration, we read characters also using deep learning, and we read codes, in this case data matrix codes, using these two libraries, EasyOCR2 and EasyMatrixCode, running on the Raspberry Pi. This is another example of how our embedded version of Open eVision can run on a very, very light and low-cost architecture.
Well, thank you, Mark, for taking the time today to go through all this with us. If you do want any more information on anything that you've seen here, visit www.euresys.com.